Hi, I'm Andrew Hubbard, and this is my MEMS5001 final project report, produce for the week. The problem statement is which produce to purchase when grocery shopping for the week. There are a couple controls that you can set based on your preferences. C0, how stringent the user wants to meet the recommended daily values, the importance of minimizing calories, the importance of minimizing cost, and the importance of having a diverse selection. So those are the objective functions: cost, calories, and variety, with the constraint being meeting the recommended daily values. To handle multi-objective, we're going to use weighted sum method, and for the optimization method, we'll use genetic algorithms. So essentially, each item has attributes on a per package size basis, and the amount of package size is varied to minimize the calories and cost while maximizing variance, all in accordance with the user's preferences. The variable x is a 1 by 35 matrix representing the number of packages of each item to buy, where every element of that matrix is an integer between 0 and m, where m is the maximum amount of packages of a certain item you would want to buy. The constraints are total daily value for each item, and it comes into the A matrix, which is an 18 by 35 matrix of the percentage of daily value for each constraint for each item, where A times x transpose must be greater than the total daily value. So the weighted sum fitness function, first we take in the preferences with those C values. We have weight conversions that essentially where a value of 1 will make that constraint no longer active, and a value of 5 will make that constraint doubly active, or will make that, that objective function doubly active or not active. And then EQ1 and EQ2 are there to normalize the values of each portion of the objective function in an unweighted manner. And then the adjustable constraints essentially define the threshold at which you meet the daily value for each item. But there are some vitamins and minerals that you don't need to meet the full daily value of, because for this set of items, the averages of those particular vitamins and minerals would make it very difficult to meet those. And then the lower bound and upper bound are defined below with the 0 and then the maximum number of items. The genetic algorithm is essentially you have the integer constraint, and then you want to set the max generations 2500 with the max solid generations 2000, because the algorithm tended to reach the optimum after roughly 500, 600 generations based on the weights of the objective function, where if you had a 1 for certain objective functions, you would generally get there in less generations. But generally 500, 600 was enough. And so here's some examples of different C values, and it shows them both reaching it around that 500, 600 mark, and then flattening out pretty well. And then the output is an array, essentially, that gives you, it compiles a list of each integer value, converts the integer value to the correct amount of the item based on the package size. For example, the eggs package size is 6 eggs. In the solution, the integer value for eggs was 2, so it prescribes 6 ounces of eggs or 12 eggs. And essentially, this is creating a shopping list for you to go shopping with. It removes all the zeros to keep it clean and tidy, and then it arranges the values into a string array with the items description. The second output lists the total calories, costs, and cart weight for the 5 days of produce. Invariance and function value were just used for validation purposes while developing the program. In terms of results for the program, with the maximum number of items being 3, the number of possible combinations would be 3 plus 1, so 4 to the 35th, where 35 is the number of variables, which is roughly 1.26 trillion combinations. And with 500, 600 generations, a population size 40 per generation, we generally reach the optimum in around 24,000 combinations, which is around 1 quadrillionth of a percent of the total number of combinations, and shows this is a pretty efficient optimization.